Welcome to another stream. Today we're doing Z sorting for the rendering library because we had some sprite flickering for sprites that were kind of misaligned, and then we'll do collisions after that. So we'll see how far we get, and yeah, that's what we'll be doing. Oh, my chat thing said like couldn't connect. What's up, 2FA? How you doing? What's up, TLK? Great new camera. Yeah, I changed some of the settings on the camera, and it was at like 720p and it was at 10 FPS, so it was really laggy. So now it's a lot better. I just had to change like the color mode of the camera to something different, and then the FPS went to like 60 or no 30, I think. Oh, you know we got the dog cam, Matt. You know it. Anything for clicks, you know what I mean? This is my brother's dog. It's not my dog. So it'll be we'll probably have him around for today and Thursday, but after that he'll have to go home. He'll have to go on home. It's not in the title or the thumbnail, so it no count. I can change my title. The problem is you can set like unique thumbnails. I just have one that I use for every stream though. All right, title's changed. Dog cam special. Yeah, now with much dog. Yeah, I should have done I do square brackets for like the intro thing. I don't know why. I feel like curly or the rounded like parentheses just they don't stand out enough. Yeah, we already did our walk today, so now we're just relaxing. So yeah. Oh, I also I finished up the interpolation stuff. So now you've got this, I had this little box that shows where the network position just told you it should be. So you can see there's jitter there. Oh gosh, what am I doing? There we go. We'll zoom in here. So you can see how it jitters. Like this is the network position that we just got over the network. And then you're always interpolating to that position. So you're always smoothly moving to it. So like when the physics simulation runs right now, technically it thinks you're here, wherever the network last told you you were. And then we do some client prediction, because like let's say that up here's the next point where the server told you were, and then like back here's the last point. The client will do a little bit of prediction to like guesstimate that you're going on this path, and I'll make another video about this, but disable the client prediction. Oh no, I just left it enabled all the time. So just because I thought it was kind of an interesting thing, because you can see how it would have stuttered, but it doesn't stutter now. I figure most people aren't like actively playing this too much because it's just kind of run around and do nothing. But eventually I'm going to take the box away. So that was more for just like demonstration purposes. But it's kind of cool to see the stutter. I did international lag, like probably what a lot of you guys get in Europe, but I actually wasn't able to get it to move that smoothly. So I think what I need to do there is I need to have a longer buffer of positions, and because the delay is so long. which is going to put you like way back here compared to what the server has, but at least it'll be smooth. So it's just hard when the latency is like 300 milliseconds, and there's a lot of jitter to it too. I wonder how much people I can invite before the MMO dies. Yeah, about 24 right now. It's on a micro instance on Google Cloud, so it doesn't host that much, but yeah, you can. I think Conifer, maybe it was Conifer or Jomi or both of them did this. They both logged in with like tons and tons of tabs until it just crashed. I think the server takes up most of the performance. I think the proxy is actually pretty low performance. What I might do is I might host the proxy on in the cloud and then set up like a little desktop in my other room and have that run the game the whole time. Because it'll be like 4 cores. It'll be way faster. But that was just like a minor update from because I was doing that network interpolation last time, but I didn't actually finish it on stream. So I did little recordings of it. I'll make a video about it eventually, but yeah, that's where we are. We're getting close. Oh, but today what we're fixing is this. We want to go here. I kind of started working on this. Also get a sweet like sweet zip thing that pops in. Yeah, Z indexing time. See how it flickers? It's hard with the boxes, unfortunately, but the flicker is the issue. But it's hard because here's the thing. Here's why this is gonna be hard. It's so hard to position them because of the little slide, which I'm not a super big fan of. I think I might need to tighten up some of the interpolation once you're really close, like you were just moving a little bit. But we'll figure it out. The hard part is you can't just do Z index 69420 is my favorite. I believe it. That sounds about right. That sounds about right for you. There's different ways of doing Z indexing, but the challenge is like you can sort stuff in software, you can sort stuff in hardware too. The problem is that the depth of this, like if you just take the Y position of everything, right now everything's Y positions on the center of the sprite, then the Y position of the person's here, the Y position of the hat is here. So what might happen is, man, it's really hard with these boxes to explain, but what might happen is that this man sprite would be in front of this man sprite, but this hat sprite would be behind this man sprite because this man sprite's a little bit further in the Y index. So what I have to do is I have to somehow come up with a way to determine the depth, like the sort direction of this, based off of the like bottom position of the sprite. So I was thinking of a few options. One, I could either shift the geometry of this, because everything's just a quad, like the hat's a quad, the man's a quad. I could either shift the geometry up so that it's centered around this point and then sort it that way, or I can batch these two together into one sprite and then center it around the bottom of that. I think what I'm going to do is I'm going to batch these together, because I think shifting the geometry is, and I've thought a little bit about this already, I think shifting the geometry will just affect any other rendering of that hat sprite because it's all pointer. So I think if I batch it into a new object, that'd probably work pretty well. Like the disconnect check happens. But what's up, Dracula? How you doing? I have tons of production CSS using that number. Oh my gosh. I am also fine. I'm doing well. It's been a pretty solid week. Finished the video, which felt good. It took a super long amount of time. I don't know if I can handle doing benchmark videos, just because there's so much little things you have to go and do. Like you can't just write a script and then like record yourself and then clip together some things. You have to like actually do a bunch of simulations and look at the data, understand it, interpret it. Hope you interpreted it okay. But it was fun. I definitely learned a lot on that project, so that's the good side. But oh, I was testing out actually I was testing out this behavior where I would just set the translation of the sprite, which would go and set the translation of the underlying mesh. And um, if it changes, we basically calculate the delta between the two translations and then translate all of the geometry by that amount. I can show you the problem I was seeing. Base sprite. Oh, this was oh, the hat's all messed up now. What the heck? Oh, I think I'm not calling set translation anymore. This is in anim, I think. No, this is in render. There we go. When I was doing this before, I was seeing the hat jitter a lot. I guess maybe it was only when I had two windows open. I need to get rid of these boxes. Client? Client? I think I'll have to, yeah. Debug sprite, we gotta get rid of that. All right, no more boxes. This is just in the local one, but yeah, boxes are gone. It was weird. I was seeing it yesterday. Sometimes the hat would start stuttering in like the opposite direction. But now it actually looks okay. Because right here, I'll show you guys what I did. This was yesterday. Like you have your quad, which is just 4 points, right? And there's a little like man picture inside of that. And then right now, the center point of that quad is right here. And it's determined by like half the width and half the height. So what I did for and I guess you technically have like another quad, which is right up here, which is the hat. Right? And then I basically match up this geometry on top of that, but the center point of this one's here. But so what I do instead is I translate it so you have the man sprite whose center point is here. Then you have the hat sprite hat man. And I basically shift all of these points up. Here, I'll draw these ones down here. I basically shift up all of these points so that they're centered on the same exact point. That just involves basically like determining some offset from here. And then every single one of these points gets added by this amount. So we add this amount to every single one of these points. Or sorry, we subtract it, I guess, technically. No, we add it. So instead of adding the position this way, we add the position by adding it to these ones. All of these get shifted off. And the center of the world becomes over here, not in the middle of the sprite. Yeah, I know. I wasn't intentionally trying to draw a clown, but sometimes you just luck out, I guess. We'll leave it, whoops, leave it up. But the problem with when you set the it is weird because yesterday I was definitely seeing this. Quite sophisticated to draw on how to draw a clown with a hat. Yeah, hey, I do what I can. Thank you. Yeah, it's a pretty big cat, but he does okay. Acts like a dog sometimes, but totally a cat. Barks like a dog, but it's definitely a cat. Yeah, so because sometimes I have to reset the translation. So what I thought was happening is here, I'm just gonna draw boxes because that's easier. What I thought was happening sometimes is like I'd set the translation to this amount, but then the hat would need to change to be like 1 frame higher. Let's say. So I have to set the translation to a different one. Let's say a little bit higher. So what I would do is I'd calculate this delta. This is the old spot. I'd calculate that delta and I would just add that, which I think caused some floating point inaccuracies, which caused it to like jitter a lot. But so I think that's what was happening, but I don't see it anymore. I'm worried it's gonna come back though. But the Z sorting is working technically. That was kind of the method I followed. Oh, actually, let's get them the same hat. I think that might cause an issue. Yeah, that's the problem. Is because they're both using the same sprite, and I'm changing the underlying sprite offset. Or I'm changing the sprite geometry, but I'm setting it twice. So one person's just clearing it. But as long as they animate at different times, it's not going to work. But these guys animate at the same time, so it looks okay. It's jittering a little bit, I guess, but that's the problem. So I need to copy this to a new sprite object, basically. So we'll change it to use the batch. And we'll render them both together. Try giving it a USB drive with a text file on it. If it reads it out loud, then it's a cat. If it's not, I do not believe. I'm so confused by that. Are you talking about that meme where it's a cat reading a piece of paper? So you resisted Rust temptations? I still think Rust's a good language. I don't think I was. Oh, it's the cat. Oh, that's the cat command. Oh, you got me. Now I feel stupid. I was trying to think of like, look at this. What is this guy talking about? You guys have the most in-depth jokes. Sometimes I can't keep up. I do my best, but no, I still think Rust's a good language. I think specifically it's good because of the memory safety for parallel processes. I think that's probably like the best feature that it has. Like that's the most like unique thing is the fearless concurrency stuff. But I think I think I'm gonna stick with the Go for now. Just because I know it better. If Rust was a simpler language, I would consider moving, but there's kind of a lot of there's a lot of language features to it. Been trying to avoid doing more Rust. Heard it may cause you to start using socks. Yeah. I mean, I did it for 2 days and I started buying programming socks, so I have a whole box full of them now. I haven't put them on yet, but you know, it tempts me every day. I just imagine the warmth of the thigh highs. All right, so what we're gonna do is, so we'll have to disable all of this translation stuff I was doing because that's not gonna work because we're writing back the sprite. We'll have to make a batch object and we're just gonna batch together the items. And when we draw them, we're gonna draw them with a matrix offset. We're gonna draw them with a matrix transform to like kind of a triangle batch. Then we'll draw the triangle batch. And the only thing, I think I'm gonna make it a sprite batch. And what this is gonna be is it's gonna be one mesh. This is also useful. Like for example, when I render my tile map, I render it to a tile map pass, which does some batching for it. But I could now render my tile map to a sprite batch, and then render my sprite batch inside of my main rendering draw call. So that might be a performance improvement, but because this is very static. So you could also use this for static sprite batching. But that means it also carries a little bit of overhead. We're gonna have to set a texture. We don't actually necessarily need to. We just can set it to the very first sprite we pass in. We'll have some bounds for it. We'll have a texture. Oops, this is an interface material. I guess it's very similar to a sprite. So this one we're gonna do new. I think I have mesh. I think I called it like new mesh, yeah. So we'll make a new mesh. Bounds is going to be just an empty rect. Texture is gonna be nil. And then sprite material, I'm going to make nil as well. I think, yeah, that's fine, I think. I'm actually gonna put this at the bottom of the file though. Ooh. All right. So I have this, I have like a general draw function, which I think is pretty nice. I think it would be cool to reuse this. So I can draw to anything that implements some interface. But I don't know if that's, I'm trying to think if this will work for everything. I might just do add on here. Right, batch.add. I might just make an add function. Because I don't know how things like this are going to work. Because you can't set a color mask. You can't set a color mask on individual ones unless you're going to like set the color of the vertex. Like if you have an independent set of geometry that you want to have different color masks for, you just have to, or can you actually? I'm trying to think here. So I add it. Mask. How does mask get used when I actually do an OpenGL call? Oh, I just pre-multiply the colors, the mesh color times the mask color. That's actually not so bad. I feel like I kind of have, I feel like I already have a generic batch object in here somewhere though. So with the dog, he's napping. This is my brother's dog. I'm just watching him for the week. Just watching him for the week. Dog cam? Yeah. It's the dog cam special. I was trying to make a joke when my message in Discord. I was trying to be like, oh, last time I did a hand cam, now I'm gonna do like a foot cam. I was trying to like write it like that. I don't think it came off like that though. Unfortunately, but you know, what can you do? Sub buffer? Buffer. Haven't watched the video? We'll watch that stream. Yeah, check it out. I hope you like it. But I'm curious if I'm curious to hear what you think about it. Hmm. I'm trying to think. I don't really want to because this is very specific for OpenGL. I think this batching I'm gonna make more. I think I'm gonna make a different batch. So I think that that's fine. But I think we can do a lot of the logic will be the same, I think. Like here we do a pass, we do a render pass. We basically batch together stuff. So I'd like to reuse this code if I can. Or at least this stuff. What are we doing today? We are we're doing Z sorting because of the flickering when the sprites were overlapped, and then after that we're gonna start on collisions. So I'm basically making a sprite batch object, and then I'm gonna draw the character sprites to that, and then I'm gonna draw them at the same spots, and then I'm gonna Y sort them, like Y position sort them, and yeah. So I need to write a sprite batch object. Position X, Y. Normal. I guess I only need this stuff, don't I? I guess I only need this. Because this is generic because you can have OpenGL buffers with different amounts of, like you can have XY, you can have XYZ, like you have a vec2 and a vec3, I mean. But in here, it's all vec3s. I don't think there's any I'm trying to think of if I should just make this like try to make it generic for meshes. Uh, let's go for it. You know what? Let's go for it. We'll see how it goes. I'm gonna rename this batch. Sprite batch will now just be batch. And this is just gonna be like a mesh batch. Func b batch add. We need to add the other interesting thing is now I can, instead of having this, because I have a 9-panel sprite, which is just a sliced sprite, you know, that's a list of them. I can batch all those together now. So I can do interesting stuff like that with this. So I need to add a mesh. Meshes already have bounds, so that's fine. The bounds here isn't going to be a rectangle though, it's going to be a box, which is this new type I invented, which is like a cube but with different sizes. And it just needs a material. Oh, it needs a matrix. And it needs a this was old code. Oh, a mask. I'm just gonna do add. I'm not gonna have a color mask. Then I'll make an add mask. RGBA. And I think that that's all I would need, right? Oh, materials. Do materials have textures? Yes, sprite materials do. It's kind of hard because I don't want to. What do I do for add? I just pass in the material. But I need to make I need to make sure the material's the same. I'm not sure if I can compare that very easily. Because I think no, I must compare it. Let me look in the OpenGL code. Because I create a new buffer when I need to change materials. Yeah, so last material is material nil. Last material. So I guess interface comparisons do work like that. Let's add a material. So the material has to be the same, basically. And if the material is the same, we can combine two things. So then all we have to do is apply this matrix to the vertices of this mesh, and then also check to make sure the material is the same. If b.material, I guess I don't necessarily need to know what the texture is. Where do I use texture here? I'm just curious. I guess I don't really use it. I'm actually kind of surprised. Let me look. I want to look up. Interface types are comparable. As with channels and pointers, two interface types are equal if both are nil or dynamic types are identical with equal dynamic values. Okay, let's look at this. I could make an equals function or something like that too. Let's see, we have an interface I, we have an interface J. They both have M functions. Then you have T, name struct, U, name struct. Where's I? Oh, that's interface. I1, I2, I3, I4, J1, J, okay. I1 equals type T of foo, I2 equals type T of foo. Okay, this is mostly my situation. I3 is T of bar, that's false. Even though it's the same type, it has a different value here, okay? I4 is U of foo. That's a different type, okay, that makes sense. So it checks the type and the values inside of the struct have to be the same. And does the interface have to be the same? I like how they specify J here, but they don't actually make a J. J1. They don't actually make that anywhere. Okay. So that means we can do this. If b.material equals nil, then the material batch for this, or the material for this batch is going to be equal to material. Else, we want to check if b.material is not equal to material. We're just going to panic. If material equals nil, so if the material is already nil, we're going to set it. Else, we're going to check to make sure the materials match. And if they don't match, we're going to panic. Else, we're down here and we can do our work. Excuse me. And then here, we can copy paste some code. So we're basically going to take the mesh dot positions. We're going to loop through them. I kind of need to make another mesh. I feel like it would be really inefficient to make another mesh, add all this stuff. Like I need to copy the mesh, apply the stuff on the mesh, and then put it in the destination. It would be nice to just put it straight into the destination. How do I append? The problem is I can't. I'm trying to think here. I kind of want to append this, get the value, get the slice range back of what I've just appended, and then update that section. But I don't really know how to do that. Like I haven't really built an interface around that. I hate when LSP stops working just because something's not compiling. Oh, this is a box. C. It's gonna be matrix. Do matrix.apply. Then pause buff is where we're gonna put that, and that's the part I'm not really sure about. So I either build this all up into another mesh and then append that mesh, which gives me one extra copy, or I build this interface, or I build an interface that's that maybe lets me add things individually. It's just really hard to, if I'm adding like positions and then I'm adding indices later and I'm adding stuff like that, it becomes kind of hard to make sure that it's added properly. But I guess I'm internal, so I can kind of guarantee that I code it right. I'm just going to make a new mesh for now and then append it. So we'll do this. We'll have like a pause buff. That's just going to be a bunch of vec3s. So we're going to apply apply this. And we're just going to store it directly into here. So we take the mesh position, we apply the matrix to it, and then we store that into the pause buff. We'll do this for every single thing. Positions, we have normals we need to do. Normals, call this a norm buff. At the end of this all, we just need to make a new mesh. Positions, pause buff, normals, norm buff, colors, call buff, text chords, I don't know, text buff, indices, bounds, to do, oh, then translation, something I can get rid of. Yeah, okay, cool. Now we just need to go through and make all of these buffers. Then we'll take the mesh and we will append it. We have our current mesh, which is, where are you? b.mesh dot append m2. And that'll append it, and that will have a kind of this batched mesh, a bigger mesh with both things applied. All right. Oh, normals are different. We need a renormalization matrix, which looks different. We get that, we go through the normals, we apply it with the renormalization. Renormalize mat.apply of the normals. We'll put that straight into the norm buff, and that's this basically. Colors, this should only matter if I have a color. Let's do this. Color add mask. This really isn't that hard to add in. And then we'll make an add function. And this is just going to call b.add mask, but with mesh, matrix, material, and RGBA. Shoot, I think it's just all ones. Like that. And that should be white. Okay. So that'll call this. This will be our normal thing. So we need to change the colors now. Colors RGBA is this one. Normals are vec3s, I'm pretty sure. Yeah. Colors are vec4s though. Mesh.colors. Call buff I, vec4. This is going to be that. So the ith index, I think if I had like a vec4 multiply function, I could get this out of here, but let me do it to do. Oh, I'm making this a oh no, it is a vec4. Yeah, that's fine. Masked out. Yeah, because we're taking an RGBA color, which maybe arguably should be a vec4 type alias or something like that, but text chords should not change. Did I miss a why isn't this back? Oh, I missed a parentheses. Vec2, make a vec2 with length mesh.text chords. We'll go through each one and just copy them over. I wonder if a copy function's faster than this. Because I'm literally doing a copy here, so that's something that I can just change. Wait a second. Yeah, the hard part is I can't modify the underlying mesh. Ideally though, I should copy it to the destination and then apply all the matrix transformations on top of that section, that which might be faster. I don't know. To copy all the buffs to the destination and then operate on them there. That might save you a copy. Which this could really add up if you do it a lot. So we'll have to benchmark that and see what's faster at some point. We'll do it at some point. But for now we don't gotta. For now we're just chilling. All right, so that should be mesh batching. Watch this compile first try. Oh, guess not. Oh, yeah, okay. That's an easy fix. Just gotta do that. Oh. That's weird that I would, oh, because previously I was using an intermediate variable. Oh, and then I've used this C dot everywhere because I copy pasted my code. Let's just do this. Replace C dot with nothing. Can't find indices. Oh, this is going to be... Oh, I just need to copy the index buffer as well. Nothing works first try. Yeah, I should have learned that by now. Mesh indices. Okay, so we'll copy the indices over. Do you use Pixel Library? I do not know. I used that originally, and I think it's a good library too. It didn't have WebGL support, which was the reason that I stopped using it. I tried to add it actually, but it ended up being a really big project, and I kind of gave up on it and just wrote my own. But I do reuse some of the concepts that Pixel had. So I think that it was a good interface. It's very 2D specific. Mine's more 2D, and I'm hoping to hopefully do 3D eventually. But so yeah. But I think Pixel overall is a good library. I don't know if anybody's made any like games with it or anything like that, but or like big games, I mean, like release an actual game with it. Okay, so set translation got removed. So the hat's being centered, but the mount it should get batched together, and when it batches together, this mesh should be added with a matrix that shifts it up, basically. That's what we'll have to do next. So that means that we'll do like a little quick software batch, and then we will and actually I have this multi-sprite thing, and right now what this is doing is it's just like literally for loops and renders the sprites, I'm pretty sure. When I call draw on it, like draw multi-sprite. So now multi-sprite, instead of saving a bunch of sprites, what I could do instead is, that's surprise. Oh, it's sprite because it's in this sprite. What I can do instead is I can just batch everything that gets added into this type. It's very confusing because this is a different library than the underlying one. So this one's more low level, or sorry, the glitch stuff is more low level, and this is kind of more for working inside my ECS. Yes. So when we draw, oh, actually, I wanted to go here. So this is where we have our two animations. We have this like kind of greater animation type, which has a body and a hat. So maybe this is like character animations specifically. But what we want to do is, what we should do is probably every time the animation changes, we rebatch it into one batch. But what I'm going to do instead is I'm going to do a software batch for every single time. Set animation. This is called every frame, I'm pretty sure. Oh, we should also add a clear function. Actually, I think mesh has a clear function already, so this will probably be pretty easy. Yeah, mesh has clear. So we'll add, we'll also be able to clear our mesh, which is important, or clear our batch, I mean. Let's see here. This should get cleared. Let's just do this. Oh, there shouldn't be a texture object because we're not storing that. We'll clear the box. Actually, I think that gets cleared by the mesh. Wait, why does this have a box? Yeah, this bounce needs to be created though. B.material, we can set that to nil now. That way it can get set to another thing in the future. It doesn't really matter. Like the materials can be kind of flexible on this. Okay, doke. Let's do this. So for every animation, we'll basically do if anim.batch is nil. We're gonna make a new batch. And then we do some updating stuff, and then we draw the body. So now we want to draw the body to, I'm gonna do this. I'm just gonna block this chunk of code out so that we can screw it up a bit. We really want to do anim.batch.add. Oh, I didn't think this through because this is a sprite. Or no, this is actually an animation. I've almost made like two. I've made it too like embedded, it feels like. Let's just see. Because when you do this, you abstract. I've like kind of abstracted away all the underlying data types. So it makes it hard to have them get added in. Let me get some more coffee and I'll think about this. All right. Coffee's brewing. I'm not really sure. Well, even if I was able to add, even if I added a function in here on like a frame, let's say, that lets me add the sprite to a batch, the sprite doesn't know. Like batches, I built batches to work with meshes, and sprites have meshes, but the sprite isn't a mesh. So I can't just add the sprite here. I don't really want to do like a big compositional thing, though that is an option, I think. I don't really want to make mesh public. So I guess that's okay because everything's inside of mesh is private except for, I think. Yeah, everything in here is private. So probably be a, no, I don't like that. Because then if someone changes the mesh that a sprite has, that just kind of undermines it. I could have like a get mesh function and then batch it that way. But I feel like it's better to have a like batch function or something like that. So I could write like we'll put this down here. Here's what I'm thinking. Batch, which takes in a batch. It also takes in a matrix, which is a mat4, math, which is an RGBA, or we're that's optional. Material, which is a material. It just calls batch dot add sprite dot mesh matrix material. Hey, what's up, not unknown? Just saw your video about performance comparison with the rest. Really awesome job there. Thank you, I appreciate it. I'm glad you liked it. That video took a long time to make, so I'm glad people like it. It was an interesting project, but just I think benchmarks in general just take a long time. Because like some of those physics ticks would take I don't remember how long it got up to, but I was running benchmarks like overnight because I did it for so many, like I scaled it up to so many numbers, you know, like across so many numbers with tons of different like numbers of collisions and stuff like that. And yeah, I'm glad it all came together at the end there. So I think in here, what the syntax will end up being is it'll probably do like anim.body dot batch to do the anim.batch. Where am I setting the matrix? Oh, I'm calling draw with a transform. So this is where I should probably make it generic enough to I wonder if I look at the add function, it is already very similar. I just don't know if I want to combine these into one interface. But that would make it easy, because then this type could just be like, hey, draw at this transform. Instead of taking in a render pass, it takes in some interface type, which could be a batch. But I guess internally this must use internally this must use the render pass. And it uses the draw, it uses draw function on that. So I'd have to bubble this all the way down because of this. Which isn't the end of the world, but there might be some performance hiccup because of that though. Because it'll all be virtualized one extra level. Let's go down this path a little bit further and we'll see what it ends up like. Right.batch. Oh, because I've already done a lot of this. I think let's go ahead and combine these because I think I want the batch to very heavily mirror this anyways. And this is internally doing some batching. So we'll have to change a lot of, I'm surprised at how small of a change this is, but how much like infrastructural changes I'm having to do to get it to work. All right, this is in pass. We'll make a new type here, which is going to be a gotta go soon, Jomi. All good, buddy. Thanks for stopping in. Yeah, I'll see you later. I hope you have a good day. Yeah. Let me know. Let me know if you like it. I'm always curious for input. I don't really know what to call this. I hate to call it an adder, even though that's the function I named it, add. I'm gonna call it a drawer. Or maybe I'll just call it like a draw target. What is this one? Should this be differentiated from being a source versus target binding? For example, I'm using this now to bind the target that we draw to. Yeah, that's confusing, isn't it? This is for frame buffer targets. Like, for example, you can pass in the render pass, you can pass in a target, and that's like the frame buffer you're drawing to, which is either the window or it's the either the window or or like some other frame buffer, right? I'm gonna call this a batch target. And I think that this render pass is a batch target. What's the, this is a mesh pointer, mat4, RGBA, and material. Yeah. Okie doke. I think that that's an okay. I might rename this from add though, but that's we can do that in the future. Because these are two very similar concepts. One of them's just closer to OpenGL than the other. And they batch in slightly different ways too. They also have different rules. Like you can pass in different materials to this batch, and this one you can't. I wonder if that's an issue. Or sorry, not this is the wrong one. I meant to say mesh. This one. This one you can only pass in one material. I think that that's okay though, because so what I think how the tree will work is you're gonna batch together stuff into one batch like this, right? And then you're gonna pass multiple of these batches into render passes, and this is gonna be like a uncommon thing. Like this is you constructing one big image from a bunch of small images, and then that one big image now can get passed into here. And I think that's generally like the case. So this will happen for animations. It'll happen like once every like 100 milliseconds or something like that, which is a lot slower than this, which is going to happen every single frame. But the better I batch this stuff, the more efficient this can be. So I don't like how much extra copying I have to do though for this specifically, but I think it'll be fine. It's one of those like performance trade-offs, you know. So now these implement the same interface. Now I need to change this. We're not going to do this. I don't know what to call this. I can delete this. Have I only done this? Yeah, I think so. Okay. Target. I wonder if I should call it batch. Nah, target's better. That's actually a word I stole from Pixel because they use target too. They use it for the other type of target though. And I think they actually they do something similar to this. Okay, let's go, oops. Let's go one level up to the flow sprites. This is like my higher level abstraction, which is easier to use than the GL library. So this one has a draw function, or should have a draw function. Oh, no. I need to go to anim. This one has a draw function. So now instead of here, I can oops. Oops, not a pointer. Glitch dot batch target. So now I can specify a batch target to draw this to, and that could be a render pass. It can also be a whatchamacallit. Uh-oh. set layer. So what I did with layers is on render passes, I have basically like buffers of these like draw commands, I call them. And I basically like attempt to batch together draw commands in the order that like in a sorted order of the layers. There's kind of different like bins that you throw these draw calls in, and then you group them that way. The problem with this though is that now you're making a like batch target. Now I'm batching like how do I just delete somebody? Sorry, I'm not used to this. Report? Hide user and channel? All right. I'm surprised this doesn't go back and re-hide that user. But let's see here. Yeah, so this makes it kind of confusing. Because in this like in the render pass, it makes sense because you like the render pass automatically figures out the best way to group your draw calls together based off of the layer they're in, the materials they use, and stuff like that. But now, anim. Now this has a layer that you can set. And the expectation when you set that layer was that it was going to get drawn at that layer on the final render pass. But then if you draw it to a batch, rather like a software batch rather than the actual like render pass, then there's not really a good way to figure that out. Because it's all going to get batched together into one layer, basically. It's all getting put into one geometry. So I can either make this a blank function that does nothing, for batches. I wonder if the thing to do is to keep using render passes like I have been in the past, but instead of doing render pass dot, well, let's look at render pass really quick. I'm just curious what this would look like. Yeah, so this has a lot of like pretty heavyweight stuff in it though. And I don't really want to make a render pass for every single thing that I want to batch. What I was thinking was that, oh, I can just make a render pass maybe, and then put stuff together, and then instead of making a draw function that draws it to a target, make a batch function that just returns the like underlying grouping of a bunch of stuff. Sorry, like the underlying geometry, like the geometry all batched together that was in the render pass. But like there's a lot of stuff, like I think it's probably better to keep it separate just because they're so different. But a lot of the stuff is somewhat similar, but we'll have to keep playing around with it, I think. So that's fine. I think what I'll do for now is I'm gonna make a set layer function required by the interface. What other functions do I have in here that I might mess up or forget about? Set uniform. So like these are things that I can't put in a software batch. Like this is the only really important thing. I think I'm gonna remove the layer feature from this. That's what I'm gonna do. Because I wasn't actually using it. Like I was just saying, yeah, default layer there. Because what's gonna happen is eventually this is gonna need to get drawn to something, and I can set the layer before I do that draw. So I'll just push that logic up. Okay. Well, now what we can do is this. We can copy paste all of this. Replace the word pass with anim.batch. We also need to do anim.batch.clear. We'll eventually move this out of the rendering loop, but for now that's what we're doing. This stuff was just old comments, so I can delete that stuff. Instead of doing it like this though, oh wait a second, actually. Let's see here, hat. Yeah, so we have the hat point now. We actually don't want this. Because this was doing it the set translation way, which was the other way that we tried to do it, which didn't work. So now we recalculate the hat point, and we batch it, but with the new offset there. So the geometry will get offset when we copy it over. And then, now that we have the batch created, we can do anim.batch.draw pass. It's interesting because I offsetted both of these draw calls. I don't need to, this can be an identity matrix now. What's up, JJ? How you doing? Yep, we got the puppers cam today. We can do this now, I think. There's absolutely no way that this works, but we'll find our bugs. Can use anim.batch variable type glitch.batch as type glitch.batch target in argument. Wrong type for add method. Okay. Oh. Yeah, batches don't have a draw function yet. Which this is kind of interesting because now batches could get added to batches. Raw. Let's go to sprite. No. We want to go to the other sprite. The sprite. We just do target.add s b.mesh matrix RGBA and then b.material. That's actually kind of clean. So now you can draw batches to other batches. I like that. Oh, cool. That actually worked pretty fast. I'm kind of hesitant to say that it's working though, because I'm not really sure. I'm just surprised that the hats moved correctly. I might have, I think I have software sorting off right now. But I think this was working before. No, I am sorting. Ryan Carniato has some good videos. He made Solid.js. Oh, nice. Have you been watching him a lot? Oh, let me get my coffee. I'll be right back. All right. Figured out what the problem was. It's what I was doing when I was drawing it all, I was shifting all the geometry up based off of like 0, 0, like in the world, I mean. I was shifting everything off of that. So the geometry was getting shifted rather than, which was causing the Y sort function that I have to think everything's in the same spot. So then the Y sort just doesn't know what to do. So I think probably nothing gets sorted at all. What should happen is there should be one position, and then which is probably going to be the center of the person sprite, and then the hat sprite just needs to be shifted based off of that. So the hat wants to be centered around this point, and so does the person, and then everybody's going to be in their individual point in the world. So then the sort function will work, but the geometry will be shifted for the hat, but not for the man, basically. Oh, just started watching him recently? Nice. Yeah, I don't follow too much of the JavaScript ecosystem, but that's cool. I feel like I'm gonna sneeze. I'm like halfway into a sneeze, but whew. Okay. So in our anim function, no, not anim function. In our render function, yeah. So we actually want to steal away some of this. So when we draw this one, we actually want to do what does this take in actually? Oh, it takes in a physics transform. We'll just pass in a zeroed out physics transform. That's going to basically put it at 0, 0, the body, which is what we want. But if we wanted to, we could shift it down. Like if we wanted to center the body around the bottom point, we could shift it down here. Like that's where we would put this. But for now, we're just going to put a 0. The hat point, we actually don't want to start here. We want to do this same logic. Now the hat point's going to be based off of the 0 point rather than the original transform. And then this one, this time when we draw, we want to do I'm going to do this logic. Mat equals glitch dot mat for ident. Then we'll translate the matrix based off of this stuff, and then we'll draw it. Let's see how she does. So when they're on the same spot, though, I can see how there would be flicker. I think it's gonna be very hard to get them on the same Y. Like, unless they're starting at the same Y. Cool. That's good enough for me. I don't know if this is going to be a very efficient way of doing things. But we could change it over to depth sorting pretty easily. Now that we have like the logic of this batching put together, we would just depth sort based off of the Y of the batch rather than do it in software. I think I want to add like that way of differentiating. So yeah. All right, let's do a big code push. Life is good. Yeah, I'm doing pretty well. Just you know, coding around. We had the box. We didn't really finish adding the box, but that's fine. We added batches. We had this translation stuff. I'm gonna leave it commented out. I added software sorting and a batch target. I'll leave those options listed out just so that it's kind of clear. More translation stuff. Change to use the batch target. Draw to sprite. Oh, this stayed commented, so that's not a big deal. What is this for? Oh, this is if you try to set the image to be nil of a texture. That's not good. Cool. Added software sorting of draw commands and software batching. Flow. Let's see what we added here. Okay, then MMO, whoops. MMO, we got some changes in here. Let's take a look. We enabled software sorting. I disabled all the debug sprite stuff because that was just for some testing I was doing. Now we render the batch. I wonder if we should make this batch generated less frequently. I feel like it's a pretty easy optimization that we could just crank out really quick. Let me just take a look at that. You think you're getting CSS down? Nice. Yeah, CSS is pretty big, I feel like. That's impressive. It's really okay to do this every frame. Well, I have an update function. When does, let's look at this. New animation, that's what creates it. Load animation loads all the data. Mirror anim, that's part of loading. Play animations, calls update. Update. I could return a bool here that says, oh, the animation has changed, and then I can rebatch in that situation only. I can do that, or I'm just gonna leave this drawing every time. I don't really have like a good. I don't think it's gonna optimize that much because it's only like 4 or 2 quads that need to get copied, which isn't that big. So cool. All right. Allow that to do in, and that'll be it. Fixed Z sorting glitch or bug. All right. Let's see here. Track my ticket that I opened for myself. Let's see here. MMO. All right, that one's done. I think next we'll probably do physics collisions. But it is 9:15, so but we'll probably start on this. We're probably not going to finish it though. We're definitely not going to finish it, at least. Well, let's get started. What we'll probably have to do, or actually, let me do one thing. Sorry, let me look at one thing really quickly. Okay. There we go. All right, now we do collisions. In the past, what I've done for collisions is I've just done like an n squared, or let's close this. Or really, actually, let's open a new one of these. Discard. Actually, I have written better collision detection. The super naive way of doing collisions is just to you have your game world and you have your one thing that you're trying to check collisions against. And you have everything else in the game world. The really naive way is to just like take this one and then go through everything else and then check to see if the collisions match. And that's actually what I did for my ECS video, the last one I just released. Then there's 2 other ways you can do it that I know of. One of them is to split the world into a quad tree. And look at this dotted line. That's impressive. And then I think you split it. I don't know exactly how you split it, but you end up splitting these sub boxes until you find like I don't know, you get to a certain number of like items per box or whatever, and then you end up checking things that are inside the same box as you. So you'd basically be able to cull all of this stuff because this stuff's clearly not in your box. You're only in this box. So you get to remove all of this stuff, and then you just search the one box that you're in. The problem though is now you have this effort you have to spend, which is doing this world splitting and boxing everything together. The alternative that I know of is this. You have your guy. You have a bunch of stuff around the world. How neatly organized we are. You have your stuff around the world. You do like predefined grids, and you just check things that are inside the grid. So instead of checking against everything, you basically box stuff similarly, but you do it all the way down. Like let's say we do this. So this is one grid square. This is another grid square. This is another grid square. And you see all the grids you're a part of, and then those are the ones you check collisions for. So like this red one would technically be a part of both grid squares. I think I'll probably go with this approach. So what this reduces it, because this is an n squared check, because for this one, or sorry, in our naive scenario, it's an n squared check. Because first you have to check him against all the rest. Then you have to go to this one and check him against all the rest. Then you have to go against this one and you have to check him against all the rest. So for every one, you have to do n checks. And you have to do every check. So you have to do n checks times n checks. Is the performance difference good? Yeah. So this will be n squared. N squared. These ones are like in log n, I think. Basically you have to loop to generate the grid for this one. That's just n, right? Because you have a predefined grid. So you just say, you go through every single one and you say, hey, which grid square are you in? And then you put them in that grid square. And then after that, you have basically an n squared lookup inside of each grid square. So like in this scenario, if you had all of your entities in the same grid square, it would kind of devolve to an n squared lookup. But kind of the assumption is that most of the time your world is like a little bit spread out. So so you'll get these optimizations. So you don't really know, like, depending on how your data is distributed, you might get different amounts of performance gains based off of the lookup. But like if he's the only one in this grid square, you basically have an O of 1 collision detection, or you end up having an O of n collision detection because you have to generate the grid regardless. The other thing is I guess you have to generate the grid every single frame. So it's generate grid, and then checking's kind of like dependent. You like the defined grid? Yeah, the defined grid, this is a lot easier than a quad tree method. I think the quad tree might be, it's definitely at least n to generate the quad tree, but I think you might get better. I've never actually done it this way, but it's at least n to generate. Oops. Generating takes at least n because you have to loop through every single thing, and then you have to go through and put it into like the right section, you know? Wait, do you? Yeah, I think what ends up happening is you end up I think once you start adding like too many into a grid, then you split that grid and you move them around. So I assume it takes in. I assume you have to go through and individually add each of these to it. I can't think of a better way, but I assume you have to loop through over everything. So let's just say it's in. But then I think you get a login. Then you get a login check, but because you have a little bit of better of a guarantee of like for example, you have 3 things in this one. So we can split this, you can like dynamically decide to split this one up even further. So what'll end up happening is if you have like a really big cluster here, let me just do a bunch of dots. Let's say you have like a really big cluster right there. You can end up splitting this thing like multiple times. Like that. And what'll end up happening is now you have less checks in this like really tightly packed area. But then you have these like kind of like less congested areas like here. This could just be one big chunk. So you can basically eliminate this entire section of the world very, very easily. Regards from Brazil, you have huge inspiration to me. Oh, thank you, appreciate it. Also, welcome to the stream, Dime. Hope you're having a good day. So these are the 3 options I know of. I'll probably will do this one though. Just because it's way easier. So what it'll look like coding wise, first we'll have to do is we'll loop through all of the entities, we'll find out their position, and then we'll establish a grid. We'll have to have a predefined grid size, which is basically based off of our world. This will be way easier to code than this, I assume, because this seems kind of hard. And also for this one, I don't really know what you would do for like a really big entity. Like if you had a huge entity like that, I don't know how you would, I guess you'd put it in every single one of these boxes, which in the grid situation, you would definitely do that. But I don't know how you decide to split it. But we'll do this way. So step 1 is generating the grid, and then step 2 is checking. And it's just an n squared check inside of that. I wonder if you could do a quad tree inside of one of these grids. I guess you could. Like if it ends up getting too packed. Right, like if the number of entities inside of a grid grows to a certain amount of time, you could probably be like, oh, let's do a quad tree here. I don't know. I don't know. I've never actually implemented a quad tree. I'm not sure exactly what it looks like. I don't see why you couldn't though. Because if you just think of one of these as its own big world, you could do whatever you want inside of that. Maybe there's some performance like once you get to 1,000 entities in a grid square, you could just be like, all right, let's do a quad tree. I don't know. We'll have to the thing with optimizations is it's like it's fun to think about, but at some point it's like you really just have to like see how it performs and do some measurements, you know? Because like you don't like, especially if you're gonna make like an MMO, you don't really know like where players are gonna be. I have read though that there'll be like hotspots in games. Like if this is a town, then like there's gonna be a ton of players here, you know? So like the optimization for a grid might be to like split it down the middle so that those are all forked or something like that, right? So it's really hard. It's really hard to like I think it's good to think about the different options, but I don't think it's the end all be all. So I like benchmarks though. I think benchmarks are important as long as you're testing the right thing. I also think it's important to measure it in like the live production setting, but I don't have very much towards that yet. I have a little bit though. But yeah. All right, this will probably go into my physics library. Physics. We can do a little cleanup here first. Also, I'm trying to write these in a less ECS focused way. Like in the past, what I've been doing is I've been like relying on my ECS to handle like the aggregation of logic, but I don't think that that's right. I think I want to do it differently. I hope you guys don't mind if I'll cheat, because I know I've written something like this before. And I just want to reference it when I write this new one. I want to go to here. Go. I wrote this a long time ago, back when there was like GoPath still. Before there was co-workspaces. Go source. GitHub.com. Unit of time. Did I put it in this one? I think I did. Actually, what am I doing in oh yeah, there's also collision layers, which I didn't really talk about too much. But you might have things that are at different layers. Like if you have a bunch of players and players can walk through each other, if you have a bunch of players and players walk through each other, you can obviously put them on different layers so that they don't like, you don't have to do the collision check, and that'll save some time too. Or rather, you'll still have to do the check, but you'll be able to get out of the check really early, because you'll basically say like, oh, this is a player, he's on one collision layer. Or what you do is you have like a kind of a receiving, you have this a receiving, you have like a TX collision layer, like a transmitting collision layer. Sorry, my handwriting's terrible on this. And you have an RX layer. And this is the these are the things that you collide these are the things that you collide with, and these are the things that collide with you, if that makes sense. So players would be on the you could put like the player layer and make them like they're on this layer. This is the layer they're actually on. And then the things they collide with might be like walls or bullets or things like that. So then you end up having this like, because players don't collide with players, because players don't collide with players, every player versus player check, you can just like immediately loop out of that. So check collisions. Oh, I guess I didn't add it here. But this is the general way that I like to do it. We'll make another file here. This is my old project. I'm just pulling some stuff out of it. Physics, collision.go. This is the physics package. What we're gonna do is we're gonna have a type, which is collision layer. I like to specify two, I'll walk through this code just because it's kind of, we'll have to, we'll change this. This will definitely be changed, but this will be our reference point. Okay. So the collision layer will be what I just described, which is the different layer that it's going to be on. And then I like to have what's called like a collider cache. This is going to hold, well, I kind of know that I'm not going to have any like physics response stuff. Like for example, if you're doing a physics system, you might have like a ball that hits the ground, and you're going to be like, oh, like what's the response of that happening? Like here's the elasticity of the ball, here's the elasticity of the thing. So it might like bounce out like this way or something like that. There's a whole like physics resolution stuff that needs to happen in those situations. I'm not going to do any of that. And because I'm not going to do any of that, I can like minimize a lot of the data that I have to hold about the collision. So all I'm going to actually hold is the list of things that you're currently colliding with, and then the list of things that you collided with last frame. And then I'm going to alternate these basically. So when I clear it, I'm basically going to flip them, kind of like a front and a back buffer on a rendering, or in rendering. Like you have a back buffer that you render everything to, and then you flip it with the front buffer. So that's basically what it's going to be. And then what you can do is I'll have one system which goes through and finds all of the collisions that are currently happening. And then I'll have another system that decides what to do with those collisions happening. So for example, if you hit a wall, it might just push you back a little bit to push you outside of the wall. If you hit a bullet, you might lose health, stuff like that. So I kind of have this as the detected. This is like all the data you need to make decisions based off of collisions. And then I have the collider be a different object. And that's worked pretty well for me in the past. So this will be like the actual layer that the collider's on. And this will be the layer that it hits. I guess I called it the hit layer, which is fine. One thing I'm not super, one thing I didn't really think about last time was because the collider, well, let me see here. What did I do? Transform.physics. Like there's just a lot of, let me erase some of this. I'm gonna erase this one. Okay. You have your world, and that's the 0, 0 of the world. Then you have like the transform that the collider's at. Then you might have like the center of the collider goes up a little bit, and now that's the center. And you have to add in all of this stuff to check every collision, which is a little bit painful, but I don't really have a better way of doing it. I guess what I ended up doing was I ended up subtracting out all of this stuff. Transform minus center. That's interesting. Collides, overlaps. Oh, this just checks regardless of the if they're disabled or not, I guess. But you can kind of see how the layer masking works here. Basically, we do a Boolean and with the hit layer and the layer, and then if they're not 0, basically, then you know that it's that they are they had some layer that interacted. I'm trying to think here. Transform minus center. Why would I do that? DX. Because you have that one, let's say. Then you have another circle over here, which has its own transform, its own center. The problem is the transforms could be really far off. Oh, this is very specific to my tower defense game. Because I actually do like a little circle projection here. Let's go comment this though. I was kind of halfway through typing that. I'm kind of hopping all around right now. This holds the I guess new collisions, that's all the stuff that needs to get appended. Also, we get here the ID wasn't in the last frame list. Oh, so this is for tracking things like if it just collided for the first time. So things that were already in the list, we can remove. But we still need a way to manage this whole interaction. I don't know if it makes sense to do square colliders at all. I'm probably just going to do circle colliders for everything in this game. But because this is a library, I don't know if I want to spend time making like different collider types. I think this is mostly right. I don't understand this though. I don't remember. I must have set, what my logic must have been was I must have set the this to be this value. Like based off of 0, 0, I must have set it to be that. Because I don't really understand this logic. Oh, this checks if it contains a point. That's kind of weird. Oh, and this checks if it overlaps. Oh, this checks if it contains a point. Overlaps, what does that do? Center X minus center Y. Yeah, so that finds, okay, so I must have done it that way then. So I must have set the center to be the total thing, which means that I'll have to have another system which basically sets the center point of the collider. So now the collider basically just knows where it is in the world, which is fine, I think. It's a little bit of wasted effort, I think, but it makes it easier to call functions on like this when you store the position inside the collider. Otherwise, you have to be like, does this collide with does like C1 collide with C2, and you also have to pass in the positions of C1 and the position of C2. So in a way, you're kind of like storing the position inside, so you don't have to pass it in here. I don't really know what would be faster, but I guess I could also pre-calculate the distance between two things and pass that in. Like I could have like a dx that I pass in here or something like that. Or sorry, like a delta. What would that be? Probably like a vec2 or something like that. And then instead of calculating this inside of here, I would calculate it outside and I pass it in. That might be the way to go. That way I don't have to have this extra loop which just sets this value. And I can just pull this out, and that's pretty easy. think that's good. I think that's a fine interface. Let's do, all right, now we can go look at, oops. There's a lot of very old code. I don't remember where I put this. Surprised I don't have a file that's called like collisions or something like that. Or I guess I have physics, but it's clearly not in here. Have I? I swear I've written this. I just don't know where. I didn't put it in here, did I? Render, particle, interp, physics. I must have put it in here somewhere. Let's do this. Oh, that's the wrong one. I called it grid for sure. Oh boy, I put in a file called config. Grid targeting, no, that's different. Oh, I have one called grid. Yeah, here we go. This project actually used Pixel. This is actually for rendering, not for collisions. I must have, do I ever check collisions in here? Yeah, this one's for rendering. Hmm. Let's check for the word collision. This must be it. Check collisions. Oh boy. Oh yeah, I wrote the exact same thing. Use a grid to offset or to offload. That's fine. I guess we're gonna be rewriting this from scratch then. I swear I've done this. I thought for sure I have. Hmm. Is dirty, get layer, bucket. How did I calculate the bucket? Layer batch. From scratch. Yeah, well, let me first figure out what I did this time. I was hoping I could just copy paste this guy and it would all just work. This is like it's very similar. This was for batching sprites together though. Because in this game I had a bunch of chunks and I wanted to batch all the chunks together like the world chunks. So I'll probably do something like this similarly. If the world grows to like a really large size, then I obviously can't draw that every single frame just because there's way too many sprites packed into one piece of geometry. So what I ended up doing was I basically go through all the sprites and add them to the grid, and I swear I've written this though. I swear I've written it for physics. I just can't remember where. This is why I need to put stuff in a library. So I have one place where it exists. I don't know where I'd put this though. Hmm. Would also be good to do a tutorial type of video. Yeah, that's true. Yeah, I've thought about making my streams into like little like stream recap videos where I just go through and like cut together the interesting parts and cut out all the parts where I'm just like, what about, I'm just umming myself to sleep. And just have all the like, oh, let's do this. Like all the parts where I figure something out. I swear, somewhere I need to calculate the bucket ID. Oh, here we go, bucket ID. Where do I get bucket? Oh, get bucket ID. Yeah, okay, here we go. Now we're talking. Bucket size. Yeah. So this is where you have to like make some amount of assumptions. Yeah, I think it'd be pretty cool. I don't think it'd be too hard to edit either. Because I basically could like watch my stream at 2x speed or something like that and just find the interesting parts. So if I stream for 4 hours, it takes about 2 hours to get through it all. I can kind of scrub it too. Like I can just scrub through the thing. So I was gonna give that a shot. See how it gets received. Get bucket ID. I don't know if there's a better way to calculate this. Why can't this go negative? Bucket X, bucket Y. How do I use bucket ID? Buckets. Buckets is a map of an int. I don't know if there's a better. I need to draw something. You have like your range of ints. This is positive max. Sorry, this is floats though, isn't it? Yeah, the position will be a float divided by the bucket size. And this is minus min. Then you have little segments. These are your bucket sizes. These are each bucket size, I mean. Or let's do this better. This is 0. And we'll just do like 2 on each side. This would also be a bucket boundary. So this would be bucket 1. This would be bucket -1. I don't think I could get a 0 bucket, could I? No, I guess if you floor down, maybe this is 0. But if this gets floored down, which way do floors go in negative? Or floor. Math.floor -0.1. Okay. And then if you do positive 0.1, that goes to 0. Okay. So what that means is that this would be bucket 0. Because these are each 1 bucket size away. This would be bucket 1. That's 2. This would be -1. This would be -2. -3. ... But now you combine them. And what I did was I multiplied by 10,000. And that just serves to offset it basically. I guess what I was basically trying to do is shift. I'm basically trying to shift one section to one set of bits and one section to another set of bits. What I really should do is make bucket ID an int64, and then shift it by 32. Like shift one of these left by 32. Does that make sense? No. Because you do need to add them. Maybe I shift them by 31 or something like that. Because I don't want to set the sign bit. It's hard, yeah, it's hard though, because if you get a negative, you can't just shift it and expect it to be correct. I genuinely don't know what happens if you shift a negative int. That's why I multiply by 1,000 instead of shifting, I guess. Man. Okay. It's been a while since we had like little spammers come in, I feel like. Wonder what happened. You know what I mean? I remember it happening a long, long time ago, like when it was very first starting. But then I added Nightbot or something like that, and I feel like they stopped. I definitely banned like a few people or a few like accounts that would do this, and then it stopped a lot. So I think there's just like, I think it's kind of hard for them to make accounts because they probably have to make like a Google account every single time. Which can't be that easy, you know? But maybe it is easy, who knows? The thing I'm unsure about is like this is y is going to be a very the y-axis is going to shift it, could shift it in a very negative direction. I'm trying to visualize in my head what this is going to look like. I wish I could just add another page. Oh, look at that. That's actually really easily. Okay. So what I'm going to end up with is y. This is the part where you have to figure out the key of each thing. You know, you have to like map this position to a grid bucket somehow. So what I was kind of doing in the past, I guess, is that I'll have the x ones just add 1 to some number, and then I'll have the y ones add 10,000 to some number, and then as long as you don't have 1,000 to x, it fits well. I'm just trying to think if I can maximize this at all, like inside of an int64, like just do the max instead of doing 10,000 kind of arbitrarily. I guess it depends on the size of your world though, right? Like if you have a very thin vertical world with a lot of y, then it might change the number that you would do. But if you have a square world, then you'd want it to be pretty even. I guess that's what the difference is, isn't it? It's how many x positions you need. How many x positions you need for every y position. So if they just specify the width in buckets, I don't know. I don't know what I'm saying anymore. Let's just write it. All right. So we'll make a grid type 2. I think we'll probably just use something like this to start off with. But to start, this holds, or I'm going to call it a spatial hash. I'm going to make this an int64. Bucket size, that's fine. Sprite sheet we don't need. This makes a spatial, this holds a spatial hash of, that's what this is like. That's what this technique is called, spatial hashing. I'm sure there's like functions for spatial hashing, but I feel like I'm pretty close to what it actually would be, so. Okie doke. So I guess we need func new spatial hash. We probably need to pass in bucket size, which will be float 64. And that's it. We might need to pass in the world size. We might also do 2D bucket sizes, but for now we'll just do the easiest thing, just square buckets. It's usually pretty easy to extend this stuff. Bucket size, and then buckets, we need to make a map of int64s, and we'll have a bucket type, and that's going to be the basically just a list of entities. I'm just going to call it a spatial bucket. This is probably just going to be a list of ECS.id. We'll import our path here. For our ECS, we can use the ECS ID field here. Let's see here. We'll make one that is spatial hash. We'll make an add function, I guess. I don't like how often I use the word add, but this is going to be a what should this be? Technically, this shouldn't just be a position. This also needs to be a like some spatial element, like a circle collider. Or like some bounding, like it should technically probably be a bounding box. Because this is going to be like the bounding box check. And then like each of these things will have a bounding box. And you'll determine which grid they're in by that. And then once you do the actual collision check, you'd use like the circle. But we'll just do circle now. And I really haven't decided if I'm going to do, I think for now I'm just going to use this as the like position of it. So that's the world space position. I don't think it's that bad, honestly. But okay, so we have a circle collider that we're going to add to the spatial hash. Let's see what we have here. We need to get the bucket ID, and we need to we also need to pass in the ID. I guess technically I could do this, add circle. And then if I have squares, I can do add square. But a circle is very similar to a square in terms of these box, like a checking if a circle is inside of a box is the same as checking if a square is inside of the box. Or it's not the exact same, but it's like physically the same. The code is different though. The weird part here though is that this object can be in multiple buckets, and I need to make sure I don't forget that. Get bucket ID of a position. It does become more complicated than rendering, because rendering I could just pick a position and be like, oh, you're going to be a part of this batch, or you're going to be a part of this batch, you know? But when you have circles, now I have to be like, oh, you're in this, your position's in this one, but your collider reaches these three, so you're a part of all three of these. So technically I need to check this object. I think the most optimal way, like the naive way, is probably to go check this circle against every single one of these hash boxes and then find which one it's in. That'd be really inefficient. So probably the more optimal way of doing it would be to find the one that you're in, you find the bucket that you're in, and then you go and you search outward until you run out of things that you're colliding with. Like you do kind of like a what's it called? Like you check the 9 around you or whatever. And then if you cloud it with this one, you check the 9 around that, you know? You do kind of a, what's it called? Like a depth first search or a breadth first search or something like that. So that we're gonna find the bucket ID based off of a position. We'll have another one which finds the bucket ID based off of a position and a collider, or sorry, just a collider. Okay. Actually, does this work? Can I just cast? I guess it's floored to an int, so yeah. Bucket ID is bucket X. Yeah, that's fine. Okay. That should be s dot s dot. This is not a valid thing. Physics. Let's see here. I'm not super happy with how this turned out, this transform object, but I think we're gonna have to keep using it. Actually, we'll just do this. X, Y. We'll just do that. And then you can basically just do bucket ID equals s dot get bucket ID for circle dot center dot x. Do I have two? Do I have center x, center y? I can't remember. Yeah, center x, center y. So I can get the bucket ID. I think for now we'll probably just be very basic and add it based off of the center point of the circle. That'll be the bucket it gets put into. That means collisions like this won't work because they'll be in different buckets, but we'll fix that eventually. Then I just do, because you don't know if that bucket's been created yet. You basically have to go through and try to get the bucket. If you can't get the bucket, then you create a bucket. And then if the bucket exists, you add the ID to the bucket. I feel like this should have a the spatial bucket should know which it is, like what bucket position it's in. I'm like so sure that I've written this. Oh, I wrote something like this. Sorry, let me just look at this really quickly. Oh, I did it for chunk maps. That's where I did it. Okay. Flow, tile map? Chunk maps. I had chunk positions, chunk size, tile size. Then I have a tile map for every chunk position. Oh, that's what I did. That's right. You can use, that's way better. Okay. So instead of doing this like stupid multiplication thing, I can literally just use a different type, which is the chunk position. So what we'll do is we'll adapt. Hash position I think these I want to have a, I want to know which bucket I'm in, or just have that data available. Bucket size, that's fine. Then the here we just do hash position. Now it's very, very trivial to know, or I technically still do need to convert it. But what we do is now we do, we have to position and, or chunk to tile. I need one that's like to, what's it called? To hash position. Yeah. Now we have this X and Y and we can just return that. Now we don't have to do any weird multiplication and like, oh, I hope it's not too wide, you know? This does force the same amount of width and height variety though, so it is square, technically. But that's fine. I think you would make it not square by doing different bucket sizes. Okay, so this will be to hash position. This should be a hash position, like so. So now we have the hash pause based off of the circle positions. Then we'll check if that bucket exists. If s.buckets, or we'll do this. Bucket, okay. If not okay, we want to make a bucket, s.buckets, hash pause equals new bucket. Should I do I'm tempted to do a pointer here, but I don't know how much that matters. I'm gonna do a pointer just so that I don't mess up with like adding things to this slice. Position is going to be equal to hash pause, and then IDs is going to be just an empty list. Okay, now we have a spatial bucket. These will be pointers, like so. Okay, so that means bucket is nil. So then we'll do s.buckets hash, or we'll do bucket equals new bucket hash pause. So that'll create our bucket, and then we'll set this bucket back to this position in the hash map because we already have the pointer to it. And now we can just operate directly on that pointer because we have the bucket available. I should maybe write it just a get bucket function or something. I don't know. Well, we can refactor if we need to. So now we're guaranteed to have a valid bucket for this one, either the original one or a new one that we just created. Now, all we have to do is add the ID. Bucket dot IDs equals append bucket dot IDs and ID. So this will put our circle inside of the bucket. And it'll automatically store it back to the hash map too, because it's a pointer. So we should be all set for that. Um, is this all we need? I think the next thing we would have to do is just loop through each bucket. So we need a way to get all of the buckets. We get all the buckets, and then we get the ID slice out of that. So maybe this shouldn't be public. Yeah, we'll do lowercase. IDs. That way we're not leaking that out, because we'll have to have like a get IDs, which will return the slice, but not the original, not the underlying slice. It'll return a just a list of IDs, which they can then be looped over. We can do the collision detection based off of that. We'll basically put everything into a bucket, and then we'll do the collision detection based off of that. But we'll have to do that next time. I think we'll be able to finish it next time, because I don't think it's that much more work to do after this. I think that this will work. I'm not gonna, I can try to compile it. Yeah. We'll leave it in a unfinished place, but I gotta eat because I woke up pretty early today. So that'll be it for today, everybody. Thanks for stopping in. It was a blast. Happy we got the sprite batching working, and yeah. All right, I will see you guys later. Yep, see you, Mountain Shark. Have a good one.